Peter Pan, that's what they call me. I promise that you'll never be lonely. Peter Pan, that's what they call me.
Mathematics, please welcome Ron Rivest.
Good morning, everybody. Wonderful to see you all here. It's amazing, 40,000 people. I remember when it was just 60. Today, it's my pleasure to present the RSA 2016 Conference Award for Excellence in the Field of Mathematics. This is an award given to pioneers in the field whose contributions and innovations are recognized for their lasting value. The selection process is rigorous and the competition is intense. Only the very best are so recognized. I'm happy to announce that this year's winner is Professor Uli Maurer from ETH Zurich, where he's a professor of computer science and head of the Information Security and Cryptography Research Group. He is an IACR Fellow, an IEEE Fellow, and a member of the German Academy of Sciences. I would first like to read the award citation itself. For fundamental results in information theoretic-based cryptography, and analysis of cryptographic protocols and primitives. Let me elaborate a little bit. Professor Maurer has been a pioneer in the development of means such as privacy amplification for secret key agreement based on information theoretic principles. He has shown how Alice and Bob can agree on a secret key by public discussion, as long as an eavesdropper doesn't have perfect hearing. He has contributed in many ways to the foundations of cryptography, including a fast way to generate prime numbers and a universal statistical test for random bit generators. His work emphasizes the importance of provable security. He has, for example, shown that under certain conditions, the Diffie-Hellman problem is equivalent to the discrete logarithm problem, a very significant result. A similar result of his shows that a generic ring attack on RSA can be transformed into an efficient factoring attack on the RSA modulus. Both of these results lend support to the security of Diffie-Hellman and RSA. More abstractly, he has refined our notion of indistinguishability of cryptographic systems and introduced the notion of indifferentiability, a key tool for proving design secure. He has worked on many more aspects and applications of cryptography, including payment systems and public key infrastructures. He has guided numerous highly successful students over the years and has made and solidified ETH Zurich as an internationally recognized school of advanced cryptographic research. For all these wonderful contributions and many more, we hereby award Professor Uli Maurer the RSA 2016 Conference Award for Excellence in the Field of Mathematics.
Thank you, Ron, for these kind words. Thanks to the conference organizer and to the selection committee. I'm deeply honored by this award, and I do realize that it takes a quite bit of luck to win such award, because there is plenty people out there who also deserve it. I would use this opportunity to say a few words about my personal view of understanding of cryptography to science, and very might be my heading in the future.
Cryptography is that fantastic scan that came to life in 17th with the seminal paper of Vesey and Helmet and British Trimanuel RSA and the cover of the foundation paper, and signed then we've seen and contains flow of intellectually beautiful ideas of the numerous practical value, including public key photography, basic signatures, technology proof, a numerous debit and cash, and so on.
Despite all of this, and despite the fact that the internet that would not be what it is today without cryptography and without this innovation, despite all of this, in my personal humble opinion, cryptography is not yet mature, and isn't in childhood, perhaps isn't in adolescence. Don't get me wrong, it's a kit that any parent would love to have. Okay, it's a brilliant kit, but it's not grown up yet.
For example, how can it be that in a view of the collective enormous intellectual power of the entire community that we still don't get things wrong? More concretely, essential protocol like TLS and other protocol get frequently broken, then fixed in the past, just to be broken again. Okay, obviously something is wrong.
What is missing? In my opinion, what is missing is a clean multi-layer theory that allows to build application from cryptographic protocols from clearly understood model. And such then the security proof for the overall system follows immediately from the quick, simple security proof of the module. Contribute into such a theory and applying it to the design an alternative security protocol is the key focus of current and future research, and this work is the announcement to continue long phase.
To conclude, I would like to thank my collaborators and my PhD students who provide the constant source of this inspiration, challenge, and supports. And I would like to thank to my partner, Natalie, for her invaluable support. It is a great pleasure to be a member of this exciting community at such a time. Thank you.